Japan, once known for its pacifist stance, has shocked the world with a bold and unexpected move. Their groundbreaking development has sparked curiosity and interest, leaving us all wondering what ambitions lie beneath the surface. In an even more surprising development, Japan has sought allies beyond its conventional partnership with the United States to bolster its air force. This collaborative effort has resulted in a formidable sixth-generation stealth fighter, the awe-inspiring Godzilla F-X. This shift could reshape the very definition of war on the international stage. Escalating regional tensions and emerging threats have certainly influenced Japan's strategic decision to beef up its military capabilities. With the possibility of future conflict looming, it has become increasingly important for the country to adapt and prepare for the ever-changing global landscape. Let's dive into this pivotal moment. Let's take a closer look at the features and capabilities of Japan's blockbuster, Godzilla F-X, which has taken the world by storm. In the decades since World War II, Japan has been reluctant to significantly expand its military, especially its air force. The trauma of the war left a deep and lasting impact on the nation's psyche, leading to a cautious approach to military development. This has resulted in an air force that, while capable, currently lags behind the advanced standards set by other modern military powers. Godzilla F-X represents a significant departure from this traditional stance, marking a bold move towards a more assertive defense strategy. It signals Japan's recognition of the changing security landscape and the need to adapt its capabilities accordingly. Along with the immense devastation it wrought on Japan and its people, the war also instilled a deep antipathy toward militarism in the national consciousness. The haunting memories of Hiroshima and Nagasaki serve as a stark reminder of the enormous human cost of war. And of course, there is a military element to this confrontation. China has significantly increased its naval and air activities near Japanese territory. Live fire exercises are frequent, creating a constant sense of insecurity. They have even launched ballistic missiles near Japan's ally Taiwan, heightening tensions in the region. With all these provocations and the changing security landscape, Japan is compelled to modernize its aircraft and reduce its dependence on foreign allies for defense. This is especially important considering that both China and Russia are actively introducing advanced fighter jets into their arsenals, potentially altering the balance of power in the region. Japan initially considered purchasing Lockheed Martin F-22 Raptors, which are renowned for their advanced capabilities and can compete with their Russian and Chinese counterparts. However, the United States has imposed a strict ban on the export of these fighters to protect its technological edge, leaving Japan with few options. Faced with this predicament, the Japanese military has made a bold and unprecedented decision, embarking on an ambitious journey to develop its own sixth-generation stealth fighter. While this ambitious effort will certainly face many technical and financial hurdles, its success could equip Japan with an advanced fighter, cementing its position as a formidable competitor in the global arms industry. The journey towards self-reliance in advanced military technology began in 2009 to 2010 when the Japanese Ministry of Defense conducted a detailed study of fighter aircraft technology. This shift in perspective eventually led to the conceptualization of a revolutionary sixth-generation fighter, aptly named I-3 fighter. This next-generation fighter was envisioned to incorporate a variety of cutting-edge technology, including advanced radar systems, ultra-fast data processing through optics for level flight, advanced stealth technology, gallium nitride semiconductor for enhanced radar performance, and significantly more powerful engine. To realize this vision, the Ministry of Defense developed a unique demonstrator platform called the Mitsubishi X2 Shinshin. This experimental prototype served as a key testbed for evaluating and refining the various advanced technologies envisioned, the I-3 fighter. The X2 Shinshin allowed engineers to test and validate a variety of advanced technologies, providing invaluable insights into real-world challenges and potential solutions, developing their next-generation fighter. This real-world testing proved to be a critical step in ensuring that the theoretical concepts behind the I-3 fighter were feasible and could be effectively integrated into a real-world aircraft. Structurally, the X-2 Shinshin is very similar to a modern fifth-generation fighter design, sharing many similarities with iconic aircraft, such as the Lockheed Martin F-22 Raptor. This design choice allowed engineers to leverage existing knowledge and experience while incorporating the advanced technologies required for a sixth-generation fighter. Its dimensions are very similar to the Swedish Saab JAS 39 Gripen, with a length of about 14 meters and a wingspan of 9 meters. Weighing in at nearly 13 tons, the X-2 Shinshin boasts a powerful turbofan engine equipped with a 3D thrust vectoring system. This advanced technology gives the aircraft exceptional maneuverability and the ability to fly at supersonic speed. One of the most intriguing features of the aircraft is its experimental onboard remote control system, aptly named Fly-by-Optic. This innovative system replaces most traditional electrical cables with fiber optic cables, significantly increasing data transmission capabilities and increasing immunity to electromagnetic interference. The entire airframe is embedded with a series of micro-antennas designed to meticulously analyze incoming radar signals. This advanced radar analysis capability allows the X-2 to effectively counter and prevent radar detection, significantly enhancing the aircraft's stealth capability. The X-2 Shinshin prototype has proven to be a resounding success, demonstrating the feasibility and effectiveness of many advanced technology. Many of the systems introduced will likely be incorporated into the final design of Japan's sixth-generation fighter, the Godzilla F-X. This twin-engine fixed-wing aircraft boasts a sleek and aerodynamic design, standing 4.51 meters tall. The truncated delta wing, complemented by an advanced flight line extension, allows the aircraft to safely maintain a high angle of attack, providing exceptional maneuverability in air combat. Two vertical stabilizers are located on the trailing edges, enhancing the aircraft's aerodynamic performance and stealth capability. Designed for a single pilot, this advanced fighter also incorporates a retractable tricycle landing gear configuration for versatile operations. Aerodynamic control surfaces and two rectangular air intakes on either side of the cockpit further enhance the aircraft's performance and maneuverability. In addition, its distinctive S-duct design, similar to that of the F-35, has significantly increased aerodynamic efficiency, reduced drag, and improved overall performance. Following the invaluable insights gained from the X-2 Shinshin program, the Japanese Ministry of Defense initiated the initial development stages of the Mitsubishi F-X, known internally as the 26DMU. In 2020, this twin-engine stealth fighter, designed primarily for air superiority, began to take shape. Significantly larger than its predecessor, the F-22 Raptor, the massive aircraft has earned the fitting nickname Godzilla. This increased size will give the F-X exceptional operational range, allowing it to patrol large areas and project power far from its base. Furthermore, it will boast a large internal weapons bay, capable of carrying a wide range of weapons. In addition to its massive size, the F-X is being developed with a focus on unparalleled networking capabilities, allowing for seamless communications and data sharing with other friendly forces. It is also expected to carry more missiles than the F-35, significantly increasing its firepower. The development team has been meticulously exploring various exterior designs, using 3D modeling and specialized virtual simulation software to evaluate their effectiveness. The main design priorities for the F-X are speed, agility, and stealth. To achieve these goals, the aircraft will incorporate advanced composite materials that enhance flexibility and significantly reduce overall weight. To further enhance performance and reliability, the F-X will replace conventional hydraulic systems with more efficient and lightweight electric actuators. In addition, it will use advanced adhesive bonding techniques instead of traditional fasteners, further reducing weight and streamlining its structure. Powering this formidable fighter will be two advanced XF9 engines, each capable of producing more than 20 tons of thrust. These engines incorporate three-dimensional thrust vectoring nozzles, providing unparalleled maneuverability in air combat. The innovative engine design also contributes to improved stealth capabilities, reducing the aircraft's infrared signature. The FX will be equipped with a sophisticated sensor suite, allowing it to effectively detect and attack even the most elusive stealth aircraft. These include a state-of-the-art, active electronically scanned array radar, passive radio frequency sensor, and an infrared camera. These sensors will utilize advanced gallium nitride technology, significantly enhancing their performance and sensitivity against low radar cross-section targets. Additionally, it will feature a radio frequency self-defense system capable of instantly disrupting radio waves globally to intercept incoming missiles, providing an additional layer of protection against missile attack. Pilots will benefit from an advanced helmet-mounted display with a wide field of view, binocular vision, full-color display, voice recognition, and 3D audio. This advanced HMD will provide pilots with unparalleled situational awareness, allowing them to make split-second decisions in the heat of combat. The FX's stealth features include snake-shaped air ducts that conceal engine components from radar and an internal weapons bay to further reduce radar signature. It also uses electromagnetic wave absorbers and metamaterials strategically integrated into its design to minimize radar reflection. These properties, combined, significantly reduce its radar cross-section, making it extremely difficult to detect. Furthermore, an improved plasma stealth antenna system will further enhance its stealth capability. This system will be able to deflect radio waves by creating temporary plasma bursts, effectively disrupting incoming radar signals and making the FX even more elusive. In addition to conventional weapons, the FX will be equipped with advanced microwave cannons capable of disrupting the guidance systems of incoming missiles, providing an additional layer of defense against airborne threats. It will also be capable of deploying combat support drones, or drones, that act as loyal companions to the fighter jets. These drones will serve multiple functions, assisting in target acquisition, munitions deployment, and even deflecting incoming missiles, further enhancing the FX's combat effectiveness and survivability.
The country was not only looking for a new fighter, but also a significant boost to its domestic aerospace industry and technological capabilities. By 1987, the Tornado had been eliminated from consideration, narrowing the options. McDonnell Douglas, seeing an opportunity, proposed a new aircraft based on the F-15 Eagle, a fighter that Japan was already familiar with and already using. After careful evaluation, Japan eventually selected the F-16 Fighting Falcon as the base aircraft for its new support fighter. Specifically, they chose an enhanced F-16 variant that General Dynamics had developed as a more affordable alternative to the Advanced Tactical Fighter program. This decision seemed to pave the way for a smooth, collaborative development process. However, as the 1980s progressed, new challenges arose. The Reagan administration's focus on strengthening the military capabilities of the Western Bloc led the U.S. Department of Defense to actively support Japan's new fighter program, encouraging cooperation and technology transfer. But the U.S. Department of Commerce had a history of controversial dealings with Japan. The trade balance had long been tilted in Japan's favor, causing considerable concern within the United States. The Commerce Department, eager to redress this imbalance, advocated pressuring Japan to purchase U.S. weapons systems directly rather than engage in technology transfer. This view was motivated by concerns that Japanese aviation companies could leverage shared knowledge to become formidable competitors to U.S. companies. Furthermore, Japan had developed a reputation for inadvertently divulging important industrial secrets to the Soviet Union, raising further concerns within the U.S. government. Despite these challenges, in 1988, the United States and Japan reached a preliminary agreement on a joint development program. However, detailed discussions and negotiations dragged on for another year, highlighting the complexities involved in such high-risk cooperation. If the FX Godzilla fulfills even a fraction of its potential, it could revolutionize the Japanese armed forces, providing them with a formidable fighter jet that is superior to anything currently in the skies. Furthermore, it promises to put Japan at the forefront of the global arms development market, cementing its position as a military manufacturing powerhouse. Another important role the FX Godzilla will play is replacing Japan's current fleet of F-2 jets. The F-2, a key asset of the Japan Air Self-Defense Force, has a fascinating and somewhat turbulent development history, even causing international crises during its development. At first glance, it may look like a beefed-up F-16, but a closer look reveals that it is a distinct fighter aircraft of its own. The JSDF, the sole operator of the aircraft, proudly calls it a 4.5-generation fighter, emphasizing its advanced capabilities and unique design. Fifth-generation fighter is actually a fairly appropriate label for the F-2, to some extent. The concept behind its development dates back to 1977, when the Japan Air Self-Defense Force envisioned a support fighter that could perform a variety of missions. The role of the support fighter includes anti-ship strikes, ground attack, close air support, and defense against airborne threats. This differs from the traditional multi-role fighter, as its primary focus is not air-to-air combat, but rather versatility and support capabilities. The Japanese Air Force initially relied on the reliable F-86 Sabre to perform these support fighter missions, which were later replaced by the domestically produced Mitsubishi F-1. However, shortly after the introduction of the F-1 in 1978, Japan began a study to explore its potential successor. This was largely driven by concerns about the F-1's limited 3,500-hour lifespan, which raised questions about its long-term viability. In 1982, Japan officially gave the green light to develop a next-generation support fighter, paving the way for the creation of the F-2. The new aircraft was envisioned to incorporate a number of cutting-edge technologies, including an advanced fly-by-wire flight control system and all-weather capabilities, ensuring operational effectiveness in a variety of challenging conditions. The new support fighter would combine advanced electronic warfare capabilities and improved air-to-air combat capabilities, giving it a distinct edge in modern warfare. The aircraft was envisioned to carry a formidable arsenal of 4 anti-ship missiles and numerous air-to-air missiles, allowing it to effectively engage a wide range of targets. Furthermore, it would boast an impressive combat radius in excess of 830 kilometers, allowing it to operate deep into enemy territory. By 1985, it was clear that indigenous aircraft development was feasible, with the exception of the engine, a critical component that required special expertise. This realization prompted Mitsubishi and Kawasaki, Japan's 2 leading aircraft companies, to embark on their respective indigenous programs. Mitsubishi showed confidence, fueled by its previous experience developing the T-2CCV research aircraft and its possession of a domestically produced fly-by-wire flight control system. They quickly began work on the JF-210. At the same time, Kawasaki designed an aircraft that resembled the FA-18 Hornet in appearance. However, concerns remained about its air combat capabilities, leading to changes in specifications and design. This constant tweaking only added to the confusion and increased costs. During the design process, Japan realized that the research and development costs associated with a fully indigenous support fighter would be prohibitive. Direct purchase from abroad was also not a viable option, as there were no fighters on the market that fully met the specific requirements of their air force. Faced with these challenges, Japan opted for a joint development program, seeing it as a more economically viable solution. In 1986, U.S. companies General Dynamics and McDonnell Douglas stepped forward, offering collaborative development based on the popular F-16 Fighting Falcon and the multi-role FA-18 Hornet. Meanwhile, European aerospace companies made a capability enhancement proposal centered on the Panavia Tornado. However, their proposed technology transfer offers and the level of industrial cooperation did not meet Japan's expectations. In 1989, the U.S. Congress finally approved the agreement, albeit with some notable restrictions. These included restrictions on providing Japan with the complete F-16 source code, maximizing work sharing for U.S. companies during the production phase, and ensuring that Japan reciprocate by providing important technology transfers to the United States. Production of the F-2 was then split between Japan and the United States on a 60-40 basis. Mitsubishi Heavy Industries assumed the role of prime contractor in Japan, with several other prominent Japanese companies, including Kawasaki and Fuji, serving as subcontractors. The engine, a key component, was manufactured under license by IHI Corporation in Japan. On the US side, General Dynamics initially led the program as the prime partner. However, in 1993, Lockheed Martin acquired General Dynamics aircraft manufacturing facilities in Fort Worth, Texas, effectively taking over the F-2 program in the United States. The F-2 made its first flight on October 7, 1995, marking a major milestone in the aircraft's development. However, some minor issues emerged during test flights, including the discovery of microscopic cracks in the main wing structure, which led to delays. After these concerns were addressed, the F-2 was officially inducted into the JSDF in 2000. Japan initially had an ambitious plan to purchase 141 F-2s. However, due to the high unit cost of the aircraft, this number was later reduced to 94. While the F-2 may resemble the F-16, a closer look reveals many subtle but significant differences. As mentioned earlier, the fuselage is 0.5 meters longer than the F-16 Block 40 variant, and its wings are a whopping 25% larger. This increased wing area allows the F-2 to carry a heavier weapons load on underwing pylons, while also improving its maneuverability. Mitsubishi also redesigned the vertical stabilizer to optimize flight performance, especially in anti-ship missile operations. The air intake has been modified to accommodate a larger nose radome, housing a domestically developed radar system. The F-2 boasts a three-piece canopy, providing better bird strike protection than the F-16's two-piece design. This feature makes the aircraft suitable for low-altitude ground and sea attack missions. Unlike the USAF F-16, the F-2 also has a brake chute, which aids in shorter landing distances. However, it is clear that Japan has taken inspiration from the United States for some design and functional elements. They have also purchased a number of F-35s, which are intended to be used alongside the Godzilla F-X when it is ready. This program builds on the significant progress made in the United Kingdom, where companies such as BAE Systems, Leonardo UK, MBDA UK, Rolls-Royce, and the UK Ministry of Defence have been collaborating since 2018 as the Tempest team. This dedicated group has been continuously researching, evaluating, and developing many advanced capabilities for future air combat systems. The Tempest team is ensuring that the security of the UK, both now and for future generations, remains a top priority for the government. To achieve this, it is imperative that we remain at the forefront of defense technology, enabling us to outmaneuver and outmaneuver potential adversaries.
The recently announced international partnerships with Italy and Japan aim to achieve exactly that. An emphasis on the interconnected security of the Euro-Atlantic, Indo-Pacific region. Work on the joint engine demonstrator is expected to begin in 2024, with an initial investment of £30 million in planning, digital design, and innovative manufacturing development. In addition, an additional £200 million of UK funding will be allocated to the development of the full-scale demonstrator. The ambitious project is expected to support a range of highly skilled jobs, including at Rolls-Royce's Filton facility in Bristol. Together, the countries will work to create a multifunctional sensor that will significantly enhance the intelligence, surveillance, and reconnaissance capabilities of future fighter jets. Japan, which has already contributed to Rolls-Royce's propulsion system, will contribute valuable technological advances to the new UK fighter. The system will be able to efficiently generate and store electrical energy generated by a gas turbine engine, using a thermal control system to increase performance and reduce the Tempest's heat signature, making it harder to detect. Japan's involvement in this collaboration is a significant development, marking a deepening of the defense relationship between the three countries. The UK-Japan partnership will also prioritize the development of the advanced Jaguar sensor system, designed to quickly and accurately detect threats from the air, land, and sea, and pinpoint targets. The system will be crucial to maintaining air superiority in future conflict. This joint effort is planned to continue over the next 5 years, with each country contributing its unique expertise and technological strength. Culmination of this collaboration could reshape the future of combat aviation, setting new standards in performance, capability, and international cooperation. all agree that there has never been a better time for Japan to develop its military power in a cashew nut. Thanks for watching the video. Click on the link that appears on your screen to watch another one of our videos. Subscribe to the channel and turn on notifications to follow the latest information on military technology. See you in the next video.